In this video, I'm going to walk through the exercise for the Town of Chapel Hill police data pivot tables. I know a number of people have worked on that, and again, we're going to make some charts. The charts will look something like this. We've got a chart of all of the hires, separated by gender, separated by race, comparing by race their average hire date and their average age at hire. So it tells us their average current age and how old on average they were when they were hired. And then a forecast, which is projecting at a year 2035, assuming that it is a linear growth, which is not necessarily the case, but if assuming that it is, what would be the average hire age of, in this instance, this is the population just filtered to non-whites. So let's answering these questions. Are police hires getting older at their higher age, or at the higher date? So over time, are we hiring people that are older than we did, let's say, 15, 20 years ago? Or even 30 years ago? How does this compare when you look at them between male and female genders? How does this compare when looking at the 4 different races in the data set? And then what are the average ages of the force by race? How does that compare to their average age at higher date? And then the last question is, based on the trend of higher age, what might be the average hiring age projected to be in 2035 for now non-white employees? And we're going to use these forecasts, we're going to use the year frac, and we're going to obviously use pivot tables. So if I get started, start here, I'm going to make a quick copy. All right, so the first thing we're going to do is get this higher age value. So there's a couple of ways you could do this. You could just do, E equals their higher age was their higher date minus their birth date. So I could do is this date minus this date, gives me a value. And then divide that by 365, right? There's a lot of ways to get that value divided by 365, tells me 23, but there's a much easier way to do that, which is using this function year frac. Tells us with the start date and our end date, what would that age be? So year frac looks like this. Start date, end date, and that's how we're seeing it. So I do that, double click through, great. So made all my calculations, and now I'm ready to look at pivot tables. So I'm going to create my first pivot table. I'm going to make it on an existing sheet. In this case, I'm going to put it at A1 of my pivot tables. Over here, click A1, okay. Create. To save us some time, I'm going to copy this and paste it across. So we're eventually going to make 5 pivot tables. So I'm going to copy, paste across, copy, paste across, copy, paste one more time. So now I should have 5. Great. So the first question is, looking back at our Google Classroom, are people getting higher? Are the police hires getting older at their hire date? So what we need to do is definitely look at hire date. So one of the values I can look at is my hire date. And what do I want to see? I want to see maybe a column, maybe another row of what is the average, or this particular people's age at hire. So for every hire that's occurred in this data set, and I can turn off totals, I'm going to see what was their hire date and how old were they at that date. So this person who was hired in 1973 was 23 at the time. And what we'll see, if I make a chart here, something that looks like this, what I'm going to look at a few things. I want to turn it into a scatter plot. And I also notice that I'm like missing points, right? So I have ages, but it's not showing the duplicates. So I need to repeat total row labels. And now look at my points. I see a lot more points. Come into my chart type, make it a scatter plot. That looks pretty good. If I add maybe a trend line, tells me obviously it's growing. I could look at that R squared and see what is the rate of growth. So I'm going to copy this, paste it into my charts. We've got our answer to our first question. Are they getting higher? Are they aging? The answer is yes. And to what degree we'll look at, we could look at this a little bit more with our R squared, but there we go. Next question is, how does that occur between males and females? So maybe my first thing is, again, my hire date. I like having that as my X. Okay. My columns can be my different genders. Don't need the totals. And then the value that I want to see for each of these at that point is their age at hire. And because there's like instances where more than one person is hired on a particular day, we're just going to look at them as an average of those ages. It's not going to, the data is a little bit imprecise, but it's going to give us a good sense generally where we are and what kind of the condition of our data, or I guess in this case the condition of our force. And I can again look at those trend lines, notice that both are increasing. I'm going to copy this chart and paste my chart in. So my next question is the same exact thing, but for races. So it says, how does this compare when looking at the 4 races in the data set? So I'm going to come back to my pivot table. If I copy this pivot table, it'll help me do a little bit of the work. Great. Looks identical to the one we just did, but I'm going to swap my race for gender, keeping that average age at hire, turning off totals, grab all 4. What's interesting to think about is that there's also like there's some data. Column P is my labels. Yes, these are not text, these are dates. Look at it again as maybe a scatter plot. There's the data is very strange when you only have 3 data points. So this is the 3 current Hispanic on staff. This is a multiracial person on staff. Like you're not going to see a lot of data. It's going to be really hard to make trends and expectations of that when you're looking at such a small amount of data to work with. But for our purpose, we just want to see some graphs. We want to understand kind of what are we seeing. And I'm going to start there. Okay, and our last graph before we get into talking about the forecast. Get rid of that. Look at my next pivot table. Question is, how do the ages at hire, their average ages compared to their hire date ages by race? So race is our X, so rows, race. I think this is going to be a table that would be pretty helpful to look at with maybe their average age. and their average age at hire. And what I think is going to be helpful here, turn off totals. That's pretty good. I think that this is going to be a chart where it would be pretty helpful to see it in columns. Looks pretty good. And maybe on our series, let's add some labels. Great. Copy this. Paste my chart in. So those are my 4 charts. And it didn't take very long because pivot tables make really quick reports, and again I could shift things around. I want to see and I want to filter out and I want to add, you can do a lot of adjustments and make, like I said, really quick reports. Pretty interesting and helpful reports. I'm missing some labels. I don't have labels on this side. Obviously this should be their age at hire, don't have my X label, don't have my Y label. There's some information that could be added by, I don't have a title label here. I could do some things there that would make maybe a little bit more interesting. So let's look, or more helpful. Now we wanted the last question, which was about projecting into 2035. What would that look like? And the answer is we're going to do, again, our age, the estimated hire date, something like that. Columns are going to be our races. So we want to look at all of our races, non-white races, and then what is their average age at hire. So I'm going to say their value is going to be, again, age at hire. Average age at hire. And I want to filter out race, filter white. Great. So I've got all these hire dates that apply to when a non-white person that's currently on the force was hired. And what I want to do now is I need to do some data, some work to this. I'm going to do just converting this date to a year. Great. And I want to do an average of these 3 columns. Great. And drag that through. Great. All right, so now the question is, if the year is 2035, what is that value going to be? And if I imagine making my chart, and I see these points, again, if I make it into a scatter, great. And I see this, and then I see 2035 over here. What would it be if I look at my line of best fit? So I can project kind of 2035 is going to be maybe close to 40. So I can estimate that, but I can also do a forecast. So I'm going to look at the function for forecast. So in this column, forecast, the known X. Again, this years is my X. We see it along the bottom here. And then it says, what are your known data for Y? So that's everything here. And my known data for X's. And with that information, what is my projected X going to be? And I should see a new point over here that is this date, 3942. And if I hover over 3942, trim that down a little bit, 39.423. Great. If I wanted to look and highlight that, I could easily come into my series, pick one data point to focus on, and it's the data point for 35. Okay. Give it maybe a different color so we can indicate exactly what that's projected. I could look at my trend line. Maybe I want to make my trend line red too to indicate that these are all kind of speculation. It's linear for sure. I can adjust its opacity. Maybe trim it down a little bit more so you can kind of see that that's where this would be if that's the projected line. Again, labels would be helpful, but as far as just doing charts and graphs and understanding this idea of forecasting, This is a pretty good little exercise. This is not far off from what real hiring departments are doing, and it's important to think about using the tools that we're learning in real practical ways. So again, pivot tables, super quick, super easy. Your first column should be, or sorry, rather your rows should be what you're thinking about being as your X, with your columns being the different types that might be on a legend, and then the position in your Y would probably be your values. And that's a good strategy. And then if we look back at this forecast, I'm going to copy this and look at the forecast function. Again, it's looking at your known X based on known Y's and known X's, or sorry, your this AK26 is what I'm looking for, given my known X and my known Y's gives me that. So again, that could be pretty helpful. And that is our exercise. And again, I think that's pretty quick, pretty easy, but makes for some pretty informative, helpful charts and graphs.